Okay, welcome to my talk, Dependency Injection in C++. And the reason it's a practical guide is I've sweated the last 4 months doing this in a very legacy code base. So it's got a lot of experience in it, but let's get on the way. So I work for Bloomberg. I'm an engineering lead there. I just finished a 2-year initiative transferring all our software to Linux. So this is the next project I'm on, which is looking at, I'm in what's called the ticker plant. Actually, before we get there, if you have questions, you can interrupt me as I'm talking. But if you have questions, there is slide numbers down here. So if at the end you go, there was a slide with something on it, please have a number so I can get to it quickly. Who am I? Like I say, I started professionally in C++ in 1991, way back. I've spent most of my career as system analyst or architect, usually on very large scale global systems. I did 21 years as a consultant, which just means I've seen a lot of companies and a lot of stuff. And I've been in the ticker plant area of Bloomberg, and that's where we get all the data from the exchanges around the world, process it and send out ticks, okay? So big volumes of data. What do I do when I come to a conference? Other than party hard, I rather do talks focused on software engineering. And the thing is, I like it to be based in the real world. So practical stuff to do, demonstrating how you apply structured engineering to actual real world problems. And hopefully you learn something here. I like to say the code does be secondary. It's more to do with how to set up your thinking and how to crack problems. And hopefully you take some of this away and can use it. So it won't be very esoteric, okay? So where will we be going with this talk? What are we going to cover? Well, this talk, like I say, is rooted in the real world system, not theory. It's stuff I've actually done and the problems I've come across. It will be about having what I call meaningful dependency injection in applications. I'll talk about what that means later. There's such a thing I think that's called conceptual dependency injection, which is where you kind of just, you know, are 1,000 feet above the ground, and then you have applied where it's much more difficult. So we'll be using various dependency injection methods for functionality swapping, usually for testability, but it doesn't have to be. And the focus is going to be on strategies of how to do DI in what I call real world systems without completely warping your code in very strange ways. And I'll show you some of them ways I came across. Or what can sometimes happen is you just give up. You say, this is really too difficult. And that kind of was the kind of feeling I was getting about the code base I was starting to try and analyze and break down. All right. So let's just get some of the dependency injection myths out of the way. All right. First is, it's simple. All right. If anyone see my badge, it had so you think it's simple. It's not simple. It's only simple for toy examples. In the real world, dependencies quickly mount up and smother you, and you have to know how to handle that. It's overkill on smaller projects. Who needs dependency injection? It's small because small projects never grow into big ones, right? So why would we put it on a small project? One of the biggest, forget for now, it's easy to add in later. All right, this is a big one because it's two things. One, it's definitely not easier later when you're dealing with real production code. But think of what you're saying. You're saying, I don't need my testing. I'll put my code in production first. My clients are my guinea pigs, and I'll get around to testing sometime afterwards, right? So you're not really doing things in the right order, it's putting the cart before the horse. And the other thing that it's only for testing. And while testing can be the immediate way you see of this being applied, all right, usually if you have something properly factored with a lot of dependency injection, you can change large parts of the code to do other stuff. So your code lives beyond its original use cases. So what do you do when you don't have dependency injection for a code base? All right, and this is how I arrived at the current code I was working with. You have what I call pocket universe testing. And what that is, you set up a barely functional full environment, right? So you're going to need toy configs, dev database components, all config files that are building up, probably singleton suppliers inside your code base. And then you do the testing. But this testing, there's I believe, three types of testing, right? You have end-to-end testing where nothing's mocked, mostly happy path testing. You have integration testing, which is what this is more like, where you put all the parts simultaneously up and you run. It's important to do this, but the problem with this kind of testing versus unit testing is it's got a lack of specificity. I think that's how we pronounce it, right? In other words, something blows up in the system, you're not quite sure what it is or what caused it, and especially if you have a lot of other changes coming into the code base from other groups at the same time. More difficult error investigation, more difficult, you write a blank check when you're trying to find things through integration testing versus unit testing. And lots of times it lies completely on regression testing, right? I know where I was, a particular test can put like gigs of state out, and I don't think anyone ever went over this and said, this is all correct. They just said at one time, I'm going to assume this is correct, and anything that differs from that is now a bug. All right, so we use dependency injection generally to get unit testing, and that's where we mock out other dependencies or other undesirable side effects. So let's talk about the essence of dependency injection, right? It's not constructors and methods and stuff like this. The essence of dependency injection is you have an interface, okay? And you have the usage side, which is what the public is using or some other class is using, and you have the implementation detail, which is hidden away. And there are times I do not want the implementation to escape. So I'm going to have data coming in to an interface, and I do not want this going out on the wire. In my case, I don't want it going down to brokers. I don't want to have a live system of a database up or cache. So what I do is I'm going to have a mock or a stub that's going to capture that data and I can analyze it, all right? And then on the other side, I'm going to be able to synthesize results. I don't have to come up with the actual results the way the whole system would do it, and then I can push that results out. And that is what dependency injection is, the ability to capture results and put back preformed data so you can check how your tests are doing, right? You have determinacy in your testing. And like I said, there's no side effects. For instance, if this was a database commit, I don't want it actually committing to the database, right? If it's a credit card thing, I don't want it actually charging my credit card if that's from testing, right? I just want it to believe that that's what's happened. And from the usage side, it should be transparent. All right, so you have a big system. How do you break your parts of your system down, right? When it's not a toy example. So you're going to have in your system a set of objects or classes that are what I'm going to call data holders. They pretty much just hold referential data. It'll be data on a trade, data on a security in my case, but it's just plain data that's in there. And they act as dependency injection points for what I call base implementations. So this is stuff that's calculated, right? Usually it's idempotent, it doesn't have state. We'll figure out from the inputs what the pricing should be, what the sizing should be on trades, okay? And then these act as further dependency injection points for your larger classes or your marshalling classes who pull these base implementation functionality in to make real world operations happen. Right here it's doing stuff for the trade. So this is how your system will break, any system will break down. And if you can keep this in your head, you should be able to do better dependency injection. All right, I got to go through some basics because I don't know. I know you're all very erudite here, but some people might not know all the basics. So I'm going to cover them quickly. So the first type of dependency injection you have is linking. All right, so link time dependency injection is something that was used way long ago. It's not used so much now for good reason, right? But it uses a link time switching of functionality. And that means that you have some limited testing because one link, one test. What it has going for it is you don't have to do any dependency insertion in your actual code, right? You reach in underneath using libpath or ifdefs, and you change what's going on inside of the class, all right? So you're going to have one for production, which has the real functionality, might be linking to servers, databases, caches. And then you'll have one for testing, where only the CPP is different. And it does very little, right? It's almost a stub. So you have a simple implementation. These alternate files tend to live in a /test/mock/stubs directory. And you get, like I say, one link, one testing scenario. And that looks like something here. So here we have a function or a class that's an action handler. It's got an execute function. and someone wants to see what the generated request has coming out, all right, I have a real com.cpp which attaches to a server, sets up its routing, lets the server know where it is. And then for testing, I have a test, right? Will just be something that says, listen, capture that data, put it in an external global, and we can grab it, okay? So what are the drawbacks of this type of testing, right? Well, the logistics of doing many unit tests this way can be quite daunting, right? If I want to do 6 different tests on a piece of code, I got to link it 6 different times potentially. You've got undefined behavior and ODR violations, because I had this happen and I tried to make a small change to the test. All of a sudden, right, we get a bunch of ODR violations because they don't stub out every function, just the ones they need. And they rely a lot on undefined behavior to make the thing work, which you may say is bad practice, but it's how it is sometimes, all right? And again, it's more like integration testing. Really, you're pulling usually a lot of the system up to get this type of thing done. And that makes it brittle and confusing. So because of that, I have the recommendation, don't use it. All right, don't use link time. If you do, stop it. And if you see someone using, tell them to stop it. All right, it's not friendly. So I'm going to take that off the table. All right, the next way of injecting dependencies into your code is using inheritance or virtual functions. All right, and what we do here is we create a base class or a base class interface, and we can put lots of methods in. It's a rich interface, so it's nice. We can put a lot of stuff in there. All right. It's also a well understood mechanism. In other words, virtual functions have been there since I started back in '91, so everybody here should have seen them a lot. All right, and in C++11 we got override, which is a pretty easy thing to understand, right? So it's using well understood mechanisms. And it's usually either easier to add in older code bases because they're built a lot on the inheritance model. Right? Older code base is OO inheritance. It was very new at the time, and people went somewhat crazy with objects and classes and thinking everything should be a class. So if you're in one of these code bases, inheritance has probably been used a lot anyhow. So what does that look like? Well, here I have a calc engine which has some functions on it, all right? And I have a process function that uses that calc engine. And here I can drop a calc engine in, and you see it does some apply with whatever data has been put in, and it does a calculate at the end and returns that result. Right, if I want to do, so yeah, there's my testing. All right, and here's the injection of the dependency. So if I want to do dependency injection in my test and isolate it, I don't actually do whatever the engine does. Let's assume it lives in another area of the code base. I want to trap the side effects of that. I can just derive off it a test calc engine, all right, and put in overloads which do not activate all this extra side effects that we're not wanting, okay? So the other thing that can happen is we can do it the other way, which is with an interface. So who here, I mean, I assume a lot of people have done this, who here likes doing the pure virtual interface and the Y pattern? All right, and who likes just deriving off the class itself? No one? Oh, one person. I like that one best, all right, gotta say, the minority here. But this is a way you can do it, gets you the same results. All right, we can push in our calc engine, and we use Google mocks and stuff like this, so the test calc engine just becomes a mock that looks like this. All right, anyone who's not familiar with Google mock, you just say the method, what it returns, the name of the method, the arguments it takes, and some specifiers on the function like const and override, no except. So what are the drawbacks of this? Well, the interface can become messy and have purely test functions in it. I mean, who here looks at an interface and there's a little comment saying, for testing only, don't use in production, right? Because I came across a bunch of them, all right? And the other thing is it become numerous. I had a class I needed to do a mock on because it was a dependency inside one of the functions I was looking to test. It had 165 pure virtual methods on the interface, right? And that's when I first gave the talk. I went back just before I came to the talk here. There's 167 methods on it now, all right? That's a lot. I don't want to sit there and do 167 methods in my mock class, so that's one of the reasons I derive off the actual class and just mock it. I needed one method mocked. I wasn't up for the 166 I did not use, all right? So these are some of the drawbacks. Anyone, any comments? It's easy stuff, right? Let's keep going. So if you're a little more cool, a little more modern, you'll say, you know, inheritance is something that the people used to use in bygone days. I'm a template dude, all right? It's much uber cooler to be templates these days. So you create a class that has, right? The calls that are made in that class are satisfied by what you're going to drop in as a template parameter. Again, it can handle lots of methods, okay? And you only need to define the methods being used. That's one of the good things about templates, right? If you don't use it, you don't have to define it. It's compile time, so you don't have that runtime overhead, that extra hop that you have in virtual functions, which if someone says to you, you put an extra virtual function in there, that's a problem. I actually put some virtual functions in, and when I looked in production, my code was running faster. I don't know why, I didn't have time to delve into it, but I think there's some optimization going on. But there is putatively a compile time speed up when you use templates, all right? And if you're really nifty and you have C++20, we can use concepts to define the equivalent of the interface in a template. All right, you can impress all your friends. So how does that look? So here's the same process again. It's got, except this time we're dropping it in as a template. All right, we have the dependency here, and we have the injection happen here. All right, and if I have something I'm going to drop in, I have my real calc engine. This is what they call non-intrusive. So I have my real calc engine, which has the apply and calculate on it. And I can do my test calc engine, right? So I can, if the real calc engine goes away and pulls a lot of algorithms for different places, trying to figure out which one to do, I don't have to worry about that. I can send back my own version of what the calc should be and check that the results hold. So that's what we do. And if you're using Google mocks, again, we just use these mock methods. All right. So since C++20, we have this idea, right, of a concept, which gives you much nicer error messages. So what do we do here? We say, look, I have a calc engine type. It's going to require I have a calculate that takes one of these const data references and returns something that can be construed as a bool. And once I have this, you'll see up in my, where I have a generic type name for the calc engine, I can just change that to the concept name, calc engine T, right? I fear I'm going to get into the 165 function thing on templates with stuff like this around. However, the better error messages almost make it worth it. Okay, so what are the drawbacks of template DI? Well, if you're in an older code base, you put templates in, it's templates all the way down. All right, and that's hard to add in legacy code base. And also, if you take a function that was in a CPP file, right, and you're going to make a template, you got to pull it out into a header type or HPP file. And when you pull stuff out of a legacy file and try and do that, you really don't have a shot. There's usually a lot of file local stuff that you can't pull out. So it's hard to do. So where people have added templates as small blocks of extra functionality, they usually have good success there. But if it's right in the, you know, the top level or layer of what you're doing, it's usually pretty hard. Right, and you get these increased compilation times, right? And if someone gets their freak on and goes wild with templates, right, it's more hieroglyphical. So it's hard to figure out what's going on. So that is templates, all right? I'll assume people will just interrupt me if they have a problem with what I'm saying. All right, type erasure. Okay, what is type erasure? Well, I can call anything satisfying a function signature. The original was a std function. And we now have move only, and it's a couple others. This is just the selection I pulled out. They all more or less do the same thing with some change in what they're doing with their arguments. So it's invocable on any target. Anything that satisfies that signature. I don't care who has the function, as long as it takes the arguments and returns the parameter, I'm good. And that makes it really versatile. And I use it a lot. So what does that look like? Well, here I have something, I call it a yield processor. All right, I have a dependency type here, which says, look, my yield function is going to have something that takes data and a bunch of something and returns me a double, which I assume would be the yield. And I'm going to capture that dependency down here in the member variable of the class. and I'm going to inject it here. Okay, and then the testing happens here. So this here, again, dependency injection, I can put whatever I want. If the actual yield that's used in production has got a lot of dependencies or pulls in a ton of libraries, I can cut them off, just like I showed in the beginning. All right. So I'm not going to do many tests. There was only one. There's another one further down. But this is just how a test would be set up. All right. You would say, here is my dependency. I'm going to inject this here is a mock dependency. It just returns 1/100th of the value. Pretty simple. I have my injection happening on my yield processor. And then I call the function. And because I have defined data coming in, I know my dependency, what it's doing underneath. I just check that the result comes out. And this is how you verify it. Okay. So is there any drawbacks to this wonderful stub function? There are. There's a couple. All right. It can handle only one method being substituted. Right. And this is a crying shame because it means that if I have a couple of methods, I got to put a couple of functions in, and that'll, grow and become a ton of dependencies. In my group, we had a function which was like stud function. It was move only, and it was stud function, but it had multiple overloads. All right, so you could just set it equal to something that took an int, took a float, took 2 ints. So you actually get a bunch of them all in the one stud function. But you guys don't have that luxury, so I'm sorry. It's similar overhead to runtime. You got that extra hop, right? Again, I don't think unless you're in the hot path of a very crucial piece of code, this stuff matters that much. And that's type erasure. Everyone okay? I'm assuming this is basic stuff, so there's not a lot. What?
The drawback is just for one particular kind of type erasure, just function. It's not a general drawback. You could write your own.
Yeah, we did. Like I said, I had a multiple overload function, so you can write your own. You go to one or two of the talks. I've seen a good one at CPP Now on it. The last thing I'll talk about is null-valued objects or stubs, and they're important in the testing domain you're in because a stub is something with no functionality and only satisfies the type requirements. So it's going to disable a part of the system that's not under test, or you don't want to test right now. You want to test one part of a big function, and all it does is takes the supplied arguments are discarded, and you return a fixed value. All right, and an example of that is if I have an interface class here, done in the way most of you guys seem to like it, right? With the interface equals the pure virtual interface. I can say I'm going to have a function where I drop the interface in, and I can make a null version of that interface. So I can say, look, where you call me with commit whatever arguments, I'm just going to return true and ignore everything. Because when I'm doing the test, I'm not interested in the database committing. I'm interested here in the results and probably other side effects. So they're disabled via the null DB being dropped in. And that is the end of the first part of the basics. Anyone want to comment? I have to go through these mechanics at the beginning. The second half of the talk has got much better stuff in it. Let's talk something else. So that's like types of dependency injection. Let's talk about methods. So here I have, if I have a pure function, and a pure function is something where data goes in, there's no dependencies, there's no state, and a result comes out, and it's the same one each time, right? It's idempotent, there's no state. Those types of functions don't need dependency injection. I don't think, because you put something in, you get something out, there's no side effects. So why would I need a dependency injection to stop the side effects, all right? And I say that a lot when I'm putting my PRs in, because some people go crazy with dependency injection. So I have something here, it's an execute function. And what this does is takes an action, and the real meat of what's coming out of this function is that request. That request has been sent down to a broker to execute a trade. So I want to know that that request is correct. But there's no way of getting it from the function. The function doesn't return, it just returns it went through, it's fine. So how do I get at this? All right. So types of dependency injection. The first type is setter, sometimes called property dependency injection. And there I have this class called a processor. Here's my dependency. It's a unique pointer of this COM down in the private area. Here's where I have the testing. How do I inject my own version of what that COM is? A mock version to stop it actually trying to send messages out or connect to a message server. Well, I can put this thing in called set sender, right? It takes a unique pointer and just moves it over. Who likes this way of doing things? all right? A smart crowd, all right? Yeah, there's the injection point, right? There's a couple of problems with this. The great thing about this is the signature has not changed, all right? So neither the execute or the constructors, nothing's changed on the class, but I do have a couple of problems, right? The class can spend time in an unusable state, right? Because that'll have nothing in it. If someone calls it, we're going to throw an exception, probably kill the work item we're working on. And the set function is probably not used in production. All right. And the reason it's not used in production is no one wants to risk putting this into production and someone having forgotten to set it. All right. So this thing is usually there just for the testers. All right. And again, why pollute your interface with test-only functions? All right. It's not what we're trying to do here. So I'm going to say again, this is something else not to use. Don't use setter dependency injection unless you think you really have to, in which case say it to you again in a mirror, don't use setter dependency injection, right? And go talk to a friend. And maybe after that, come back and not use it. So the next way of doing it is method injection, all right? So method injection, here's the same thing we had before. All I'm going to do is in the actual call to the function, going to drop in the dependency. It's very honest. You can see exactly what's been used by this function. All right. So what happens here now is I get a function signature like this. All right. So how does that look? Well, here's the dependency. Here's me dropping in my com. And that's the injection. Can anyone see any drawbacks with doing this? It's a fairly obvious one.
Is the function arguments?
No, you're on the right track. You're lukewarm. I changed the signature. All right. Now, I don't know about you, but whenever I change the signature in a code base, I get, I don't know, I won't say millions, right? I got quite a lot of warnings like, this doesn't work anymore, and here's a couple of suggestions of what might work. All right. So you've changed the signature, which can be a big deal, especially in a big code base, and a bigger deal if you have external users who are not expecting it, all right, when their code starts breaking. But I still think it's a good way to go. If your dependency changes on each method call or changes or is variable, it's not constant. And let's look at the final one, which is constructor injection. So constructor injection is where I have what was going on before. All right, so I have my execute function, which has the com coming in, but it turns out the com is an invariant. In other words, I use the same com each and every time, and I got to remember where to put it in every time I call this function. But what if this is part of a class, right? And if it's part of a class, then what I can do is I can just move it into constructor and catch it as a member. All right, there's your dependency, and there's your injection. Now you'll notice on this one, this is just the same, this is just the same thing. You'll notice here the function signature of the process is unchanged. So that's a win, right? Anyone see any other problems with this? Yeah, I'm signature changing again, right? I mean, it's just blasé. I mean, it's okay when I put it in a slide, but when I put it to the compiler, it complains. This could be hundreds of places all over. I've just changed the signature, all right? But the thing is, even though the constructor has changed, I have better class invariants, right? But a setter, I'd be like, well, what was in there at the time this happened, right? Or some rogue programmer comes along and like changes it underneath, and I wasn't aware that was happening. All right, so this gives you much better invariance in your class. All right, so that's constructor injection. That is the basics part done. So, breathe a sigh of relief. How am I doing for time? All right, cool. Roughly where I want to be. So let's talk about conceptual dependency injection, which is the easy type of injection. All right, this is what you do around a coffee cooler or the water cooler. Right, you say, all I need to do is control the dependencies in my system. So what I'm going to do is identify the function blocks and I just capture all the inputs and outputs by having flexible pieces there that I can substitute. Where do I insert these dependencies? Well, I drop all the invariants into the constructor. Any dependencies don't change. And the ones that do, I'll just drop them into function method calls. All right. And then I'll just add virtual to my class members. Or if they're static functions, I'll just create a class that says same name, virtual and call the library function, even if it's static stuff underneath, right? So this is good. This is good if you're not actually trying to do dependency injection, right? Because this is a real simplistic view of what happens. Like I said, the real problems with dependency injection is all these dependencies, and this is just ignoring the fact that I can't drop 20 dependencies into a constructor and another 15 into the method call, right? You just can't do that stuff. All right, so, and when I've seen this done, and that's good because I was doing this in the code base and a couple others got inspired and went in and did it as well, but they kind of did it in, I'd say, an unstructured way. You ignore bad interfaces when you just go in and sort of codify up something as a bunch of virtual functions because you haven't properly tightened up and checked out that the interface is proper first. So here's a warning. This is if you're some guy who's a more of a theory pumper, more of a boffin as I call it, like sits on a chair and dispenses advice. The real world starts here because this didn't help me very much in what I was doing, right? It's like, yeah, we can do this kind of stuff, but we can't. So what are the problems when you do what I call applied dependency injection instead of conceptual? Well, one of the first problems is that really basic, that the object's full creation is hidden inside of the function or the class. So there's no way to get my hands on it. All right, so there's default stuff or stuff with fixed arguments. And that looks a bit like this. When we have stuff isolated in a function, we have a class, and in here there's a processor. How am I ever going to do dependency injection on this? Especially considering I've already rejected the link time because it's about the only way I can think of getting at it. All right, or we have something even worse, right? We have something where we say, like, let's reach into a singleton and pull what we need out of it. All right. Now, these days, people are like very wary about naming their stuff singleton. All right, people are like, yeah, if I see that, it's going to trigger people in code reviews, right? That's a singleton. All right, so, you know, we call them factories or contexts or something, right? Say, this is really cool. All right, now as I'm doing is I'm getting it from my factory. All right, is it a global factory? Well, yes, it is. Is there only one of them? Yes, there are. All right, so sounds like it's quacking like a duck. So that's the problem you find, especially with a code base that has been already laid down with no idea of what we'll do for dependency injection. Next, what we have is reaching through multiple objects, right? So it breaks what we call the principle of least knowledge. All right, if I want to borrow money from, I don't know, Klaus, I'm not going to ask this guy to ask this guy, this guy, this guy, to then ask Klaus. Right? I'll just ask Klaus myself. So what happens? This is a line of real code. Okay, there is something inside of this class called an updater. And it's like a little bit of a God class. All right, and it has inside of it something, a class called a processing context. And inside of that, it has something that holds a bunch of exchanges. And inside of that, once you pull one of them out, you ask for this tick helper. And that's what I actually needed to use. All right, so this breaks what's called the law of Demeter, which is only talk to the immediate friends. How would you fix this? Like, think if I had to mock this out, right? I'm going to put a mock updater in. I've got to have a processing context call that doesn't really do anything, so I'll probably just return to this pointer. And then I'll have an exchanges call, which I'll probably just return to this pointer. And then I'll have a get call, which will probably just return to this pointer. And then the legacy helper, I'll return my mock helper. All right, you can see how convoluted your stuff becomes. So don't do this, all right? Just pass the damn thing in, right, that you need, not something that has something that has something that has something you need. And that really messes you up when you're trying to do dependency injection. Okay. Anyone, any problems with me so far? No? All right, next. This is a big one, right? This is a big one. And I've been at many conference talks where they said, don't do this, and people do this, right? So this is disentangling getting from setting of state. So again, I'm going to show you a real piece of code, right, that I came across. And what this does is there's something being handed in, called a handle, which has data in. It's got different precisions of a data. And it just goes down can I get this one? Can I get this one? Can I get this one? And it's just get, set, get, set, get, set, get, set, get, set. If I'm trying to do dependency injection here, it's a nightmare. I've got all these sets being called, all the gets being called. It's a nightmare. What really should be happening is you disentangle the gets from the sets. All right, so I just say, look, get me the price variant, which has all them types in it potentially. All right, and if I have it, just set whatever's inside of it. And this here means I'm not doing alls and get sets. And these two functions, get bid price, get ask price, now turn out to be pure functions. So I can take them out and test the heart and soul out of them without having any side effects. All right, and I need to do one test to see if it'll set the price, right, and capture it in a mock. So dig out the pure functions and stop doing getting and setting in the one function. There should be a clear divide between getting your information and changing your state. Next, this is a good one. All right, having too many dependencies in a class, right? Because it's impractical to pass, like I say, huge amounts of dependencies in a class. Well, what are you going to do? You can give up, right? That's one way. And I've seen that done a few times. But what you really have to do is do refactoring for the dependency injection. How's that going to look? Well, one way you might do it is you say, look, if all these dependencies been dropped in, this is obviously unmanageable. I got a DB, some sort of communications, I got a file loader, cache, all this kinds of stuff. And I say, well, I can narrow my dependencies down by doing this. All right, let's just put it in a bucket. Now I'm passing one dependency and I just have to pass a fake bucket in. Who thinks this is good? Did someone put their hand up? Oh, you think it's borderline good? Let me tell you why it's not good. All right. No, don't do this. Because an unstructured bucket of dependencies is no different. It's the same as having it in the function signature, right? You've just moved the problem one layer out, right? If I have a big bucket, which parts of this bucket have been used by the execute function? I don't know. Now, which parts is it? People usually won't do a bucket per function call. So I'll have to start guessing. It'll become some kind of, like I call it, a God bucket. And I won't know what's been used. It can be used, though, for types that belong together or for types that are very similar, right? If I have, I don't know, say coordinates of a rectangle, I don't need to pass the x1, y1, x2, y2. I can just pass in a pair of them. And that's proper coupling up of stuff. Or if I have, in my case, I have processing exchange rules, header rules, tick exchange rules. I can put them in a rules class. I won't call it a bucket, but it's a rules class that says exchange, processing exchange, tick exchange, header. All right, so that's a way of bucketing stuff, but not like this. Now we just take everything and put it in. So don't do that, right? Next is we can have class or class hierarchies that have huge amounts of functionality all packed into the one class. It started out probably reasonable and people just started putting stuff in, what's called complecting, right? So it's got too many things in it and there's too many dependencies. You just literally can't add all these dependencies in. And you might say, well, I'm only interested in this one, right? And try and like really sculpt your testing, but it makes the testing again very brittle. So how do you do refactoring for DI here? Proper refactoring for DI is I have my godlike class, all right? And when I look inside of it, I may do a bit of code moving. I've actually had to do this. I find out that there's buckets of functionality all throughout this code. Like there's groups of functions that are only called by one function. There's verifying, there's pricing, there's actions, all these stuff here. Now, if I was to try and drop this into the class as a bunch of dependencies, I'd have 8 arguments extra to what it's already getting. That's, I don't know, maybe some of you have a tolerance for 8 to 10 parameters. But what if each of these has 3 dependencies apiece? Now I got 24 things going in. All right, it doesn't scale. So what you need to do is once you identify these blocks of functionality, is you push them outside the class and make them into their own small blocks of functionality. Okay, the main class has still got all those dependencies. You see it's still doing 8 calls out. I haven't done anything here, but what I have done is I've made these classes here now what I call encapsulated functionality. They're only doing one thing, and they're usually pretty easy to test because a lot of them will be pure functions, and the ones that need mocking is usually pretty easy to mock out. All right, so this is what you do. Once you've done that, though, you can take a look at this kind of thing and say, there's a higher level abstraction that should be here. All right, and that higher level abstraction for me was, there's a part of this which is gathering information. I'm gathering pricing, sizing, the type of actions I can take. I got some business logic going on, verifying the thing we're asked to do is correct. apply business logic, do some rules on it. And then at the end, I'm going to have my, my side effects, right? Saving it to database or saving it to a cache and sending it out. All right, so I have now better abstractions. So what I can say is, look, I really only need to do one call to just gather information. All right, it's one call. I've tightened the interface. The interface should be really wide. Now it's just a call called gather. All right, and it accesses all these other classes inside of it, but they're already fully tested. And now what I can do is do unit testing on this higher level abstraction. Okay. And because I've whittled my dependencies down, now what will happen is the glue, remember the glue was this big amount of glue? It's gone, half of the glue has gone into these other classes as well. So your classes become easier to read and easier to understand and better structured. And what happens is you now just have, for here, 3 stages inside of my big class. Instead of a whole bunch of functionality, I have a gathering, applying my business logic, and then distributing and saving off the state. All right, but it now is not a God class. I call it a marshalling class. And from there, we also get gather information, right? So I have a gather information. It has pricing, sizing actions in it, right? Which I can dependency inject. So, but it only has 3 dependencies. Okay, and then the pricing itself may have a couple of things inside of it that I can test. So we have this tiered layer of testing. And if I want to test what's going on in the marshalling class, I can drop in a mock gatherer and say, whatever information you're giving me, I'm going to inject a fixed piece of data. And I have to say, if I was doing the actual use case or scenario, I might have to be very, very careful. I can just say, inject this piece of information back and make sure that the business logic handles it, and I'll capture it in a distribution mock. Okay, so that's how you do refactoring for dependency injection. Anyone, any questions? Cool. And then the last one is almost the opposite of that, is where you have functionality splintered all over the code base. So we have it like the logic is fragmented, and that usually means it's fragmented in utility classes. I got a call utility A dot check this, utility B dot check that, utility C check this. All right, or it's throughout the inheritance chain. I have verify in my base class, and it calls a function called verify X. And then in my derived class, I have something that says my verify actually calls the base class verify. And it goes up to the base class, and it calls verify X, which is a class member that's overloaded down in the derived class. And you get this hopping up and down of the chain. Very confusing and very splintered. So how do you deal with something? Here's a generalization of it. So I have a utility class or classes, and I got 4 dependencies just on my verifying. But if I take the pieces that verify and I pull them out of these general utility classes, right, I can make them into a component that I'm going to use. And then that component becomes a single dependency. So again, we're doing this lessening of dependencies. And not only that do I have the one dependency, and I have the ability to do unit testing on this. Because I tell you, I could not do the testing on the whole application class. It was so tortuous. But now I'm starting to pull chunks out and build up this layer hierarchy. Okay. So that's the roadblocks you find for dependency injection. And I'll just go over. So if that's the roadblocks, what is the highway express? Or is it the motorway here in England? So we have like, what is the motorway express for dependency injection? Your creation is done outside of the logic of the function. So your creation and logic are separated. And that means you pass in the dependencies directly, or you pass in something that supplies the dependency. Not a factory shoved in under the back curtain, right? It's something that's explicitly put in. Next thing, you invoke methods on immediate objects. Don't be reaching through objects for other objects for other objects. You just push in what you actually need. The guy who's calling you can do all of that stuff, right? He can call you with that big long chain. And disentangle state from information retrieval. One is read-only, usually idempotent. The other one is a lot more hassle, and I don't want to be doing information retrieval with a lot of hassle each time. So find the constant pure functions that are in there. Refactor your God classes, so take all that functionality that's inside of classes and push them out into smaller units to be tested. That's going to lessen dependencies. And the other one is when you have fragmented functionality that's splintered all over, you're going to lessen that dependencies, right? Again, by pulling them all together into functional components. I call it functional clustering. Taking like with like and putting them all together. Even if they're spread up in an inheritance chain, take the pieces out of each of them and push them into one class and call it, right, a functionally clustered class. Anyone, any questions on that last segment? We're getting into the final segment. Where's my time guy? How much time do I have? 50 minutes. Okay, all right. So legacy code is code that works for, people say there's various interpretations. To me, it's code that's working in production for real users. The minute it's in production, it's harder to change. You're going to break real users' experience. So it's harder to apply. The code is not as malleable, and you usually have a lot of external dependencies. And if you try and introduce large-scale complex changes, that's riskier, usually takes a lot of time, and management will generally not have the appetite for it. Right, so there's a preference for phased, localized changes that are transparent to the rest of your system. Okay, so you put it in and no one knows it's there, essentially. So for that you need tools and tricks. So first problem, I have an API, right? We all talked about signature changes. All right, so I have an API that's used far and wide and I can't change it, but I want to do dependency injection. All right, so you see my calc, I want to get dependency injection, I add it here. I now have broken the code base. I've made a breaking change. But I can do things, there's your injection. I can do things that just put a default parameter in. So whatever was used to be there in the beginning, calc, put a default calc in. All right, same if it's a function. This means that the API has not changed. However, we have changed the function signature. And if you have some stud functions that are using this, they're going to break. And defaults have weird behavior happening in corner cases. So you're better off leaving that the same and instead just write a forward function. All right, so it's a forward, the old function gets the extra dependency and you write a new one, which is just the same signature as the old one and defaults injects it in, right, in the call. All right, there's your default injection. So there you can make the change and no one is any the wiser in the code base, right? But you get the ability in your testing through dependency injection. Same thing for constructors, all right? I'm going to add a default in the constructor, or if I don't want to do that, what I'll do is I'll just make a forwarding constructor. I'm not sure if that was 17 or was that. If you don't have it, you got to do it the other way, right? So how do you solve problem for transparent dependency injection? Is default arguments or forwarding functions where you delegate the call to something with the extra piece that the new function needs. All right. Let's look at DI for lazy object construction. It's an interesting one because I'm not really able to pass in a constructed object. So let's look. This is a piece of real code I came across while I was doing this. I wasn't actually doing the injection, but I caught the people who were doing it when they were in the act. So the first thing was we have this dependency down here. Right? We have this unique pointer. We own this thing called a DB helper. So that's a dependency. And we have this lazy injection. If someone calls particular functions, we ensure we've loaded up. And when you call this DB helper, if you look under the scene, I looked under the sheets, it's got singletons and loads up cache and stuff like this. So it's an expensive operation. And there's times where this thing is just passed through, right? We're not actually doing anything to it. So we have the lazy initialization. So the first thing that was done is let's just do constructor dependency injection, right? We need to get at that dependency. So let's just do it this way. All right. And if we've done it this way, right, we actually don't need to say ensure anymore because we have it loaded already. So we're done. Right, we got rid of a bunch of code. We have the dependency injection. Who can spot any problems with this? Yeah, your performance just took just cratered, right? You know, you're making this thing happen every single time. You're generally not allowed to do that, at least not where you guys are, where I am. I'm not allowed just to slow things down 5 by. So that's not lazy, so you can't do it that way. So the next thing that happened is they put in a set DB helper. So they put in setter, and I caught this in the code review. I was like, why do we have this? Because I don't think we should be using it. And it's like, well, If we do it this way, and you see there's a code smell here, it's not that it sets the DB helper. It says, if it hasn't been set already, set it. And I said, well, why would you do something like that? Well, I'm afraid some other developer might change it in production, right? And all the ensure stuff is left there already. So really what we have here is a testing function that's been put in, all right, to what I call corrupt the interface. So you can't do this either. So I've suggested them a different way of doing it. I'll walk you through it. So what I'm going to do is, here's the original class. What I'm going to do is say there's a dependency provider. And this thing takes this const string reference and returns the DB helper. Now if I rewrite the class, all right, here is my dependency provider, a new member in here. I'm going to inject it up here, and you see I defaulted to whatever was there before, that create DB helper function. And then down here, I just call that stub function to get the DB helper. So what I have now is lazy dependency injection, if you like. All right, and everyone okay with this? So if you have lazy initialization, how do you get the solution? Drop in the dependency provider. Right? If it's just one stub function, if it's more than that, maybe you go to inheritance. Right? But that's how you solve that problem. Here's one that was interesting. It's an unexpected snag. I have this class, it's a header. It's a dependency in my function, so I start mocking it. I say, okay, we call a get dividend function. I'm going to have my mock method for get dividend. It's got a set model function. Okay, I'm going to have a set model function. I catch it in my testing. And I go away and I put that change in. It goes in fine. I come along a couple of weeks later doing more testing and needing more dependency, and I run across this in the class, right? So, templated member functions cannot be virtual. Now, if you want to know why, we need to know what size the virtual function table is. You can't just say it's whatever. All right, so what am I going to do down here in my mock class? Anyway, how do I get out of this? Real problem. This is not something I just dreamt up. Real problem. Well, I went and looked at the CPP file for this, and found that for the particular version I was using, it was fully specialized. Right? If it's fully specialized, I can just make it into a regular function, and that means I can just put a mock method here. All right. Now that's not really a general solution. I think I was kind of lucky there. Right? So I wouldn't say go away. That's how you solve this problem. That's way. I think I was just lucky. But what do you need to do when you have this problem? When you need to go to the point of sale of where this thing is being used. So here it was being used in this class. Right? It's looking for a type, and it's calling this templated function. All right. And I said, okay, let me put a dependency injection point here. So I'm going to have a type that's isType function. And then what I'm going to do is I'm going to capture it here as my dependency. I'm going to inject it in the constructor. I've just broken the constructor, I realize. And then down at testing, instead of saying header isType, I'll just call my isType function with the header and the val. And then I'll just make a lambda that says return header to isType val. All right, and I'll make that the default. Now, no one's any the wiser. I've solved it. How impressed are you guys? I know it's the end of the conference, but you know. It's impressive, right? And then when I want a test function, I'm just going to say, listen, return a particular type because that's the scenario I'm trying to drive through my testing of the class that's calling it. So the cannot be virtual. Now, I did this in a previous a dry run, and one of the people who was there says, hold on, you didn't actually solve the problem, Pete. All you did is you waltzed around it. What happens if I have this thing called with a lot of different types? You're not seriously suggesting I just put one in for each type and I kind of like iterate through it. Now, so I think what you're saying is, what if the apply function looked like this? All right, so now what am I going to do with functions? I can't tell. It's like, is there a way out of this? Of course there is. All right, there's the testing. I'm just going to inject it with dependency with template DI. I'm using templates here, so get out of the inheritance and start using templates. Okay, there's my injection point. And this will now actually work for my case because the mock will actually put an extra real method in for string, and that will overload the templated version that might be there. But if you really want to do it, all you got to do is put it in here, and you're good to go. And that's how you solve these kind of unexpected situations. So if you have template and functions in the middle of your inheritance DI, turn it into a regular function if the template's fully specialized for limited types to type erasure. But if it's a general thing, then move over to a templated DI, right? It's right there in the signature of the function. That's what you should be doing. All right, last one, dependency injection. I'm not even going to say what this problem is. I had a class, someone wrote, again, people get enthusiastic, they write this, and it was like, look at this class. We have something I want to test in this class here. It's a build function. And you see, it's got a real operation. It's going to append something to this tick type. And then it calls this append times function. And this append times function is a virtual private function that goes off into some other library with undesirable side effects. I don't want to do it. Right down here. And I'm like, how do you do dependency injection on this? And it's like, well, look, you inherit off the builder and you mock out that append times method. Like, show me your testing. So, right, this is what I call I am my own dependency. All right, so I have a dependency here. I create a mock builder and I'm saying expect to call the append times function. And here I'm just going to do nothing, right? It's a void, so I'm not actually going to do anything. And then call the build function on the mock class to check that your functionality is correct, right? It's not in the mock class, it goes up. All right, and then we can do the verification. This, I think, is kind of really confusing. When you first see it, you're trying to figure things out, it's really confusing. So what do you really do here? Right, what you really do here is take your dependencies out and put them someplace else. Don't have your class being its own dependency. Like this. And then you can do your testing, right? And you can put this in the constructor, right thing. So again, let's go back to the myths. It's simple. I tell you it's not when you're in a real complicated real world system. It's overkill in smaller projects. You might think that, I don't think it is. It's less work then, just do it. Only for testing. Don't think it's only for testing. I've used it where I've put in big globs of new functionality based on dropping a new dependency. The big one, forget for now, add later. So what are the truths of dependency injection? It's hard in real production systems, right? And properly factored code is the ultimate key to dependency injection for anything that's not a toy example that you'll get on a slide, all right? Now, here is the key thing. You need to give weight to local refactoring, not a rewrite of your system. You go and say, like, we need to rewrite this whole thing. Generally, things don't get done. So you need to do local refactoring, what I call transparent dependency injection. And poorly formed code needs many tricks for dependency injection. But at the end of the day, it improves the flexibility and the overall maintainability. Think of it, by putting dependency injection in your code, you've just structured it a lot better. You've pushed out functionality into discrete chunks, right? It's properly factored. If I say to you, factor your code better, it means different things to different people. But if I say, factor your code however you want, but give me unit testing on it, you're forced into doing these kind of things. And you've better long-term maintainability of the code. So dependency injection applied ultimately boils down to lessening the number of dependencies that need injection in an interface. Remember I said the essence was the interface? It's bringing them down is the absolute #1 goal of what you're doing when you're doing dependency injection. And I say you have a horizontal abstraction, which is taking refactoring codes and pushing them out into discrete chunks. All right, and then there's the layer where you say, look, I'm going to build up my testing by each abstraction layer having dependency injection, but start at the bottom. If you start at the top, you encode a bad interface generally. So when you do the stuff at the bottom, it's going to determine what kind of interface it needs. The stuff on top then gets determined on it, and that builds up and you get a proper interface. It's usually a lot tighter. Like I've taken, I don't know, I think 60% of the code out of these big inheritance hierarchies, pushed them into other classes, all right, and tested them. And people are amazed I don't use feature flags when I do this because I'm changing the most sensitive parts of the code in Bloomberg Ticker Plant. Think of it, 1/4 of the data that goes through Ticker Plant every day is going through 6 classes in a hierarchy I did this on with dependency injection without feature flags. All right. Okay. Other talks I've given. Well, that's the end. Sorry. End of talk.